Good evening, Rahul.
Good evening, Wisdom Tree.
How was your day today? What did you learn in the class today?
We are still studying decimals. Our teacher asked us to learn equivalent, like and unlike decimals for tomorrow.
So, have you studied them?
No, Wisdom Tree. I was wondering if you could narrate me a story on how the Pandavas and Kauravas learnt about equivalent decimals. Your stories are interesting.
Sure, Rahul. One day, Nakul and Sahadev were having a competition among themselves on who will plough more land in the given time. The land allotted to them were equal in area. Nakul's land was divided into 10 squares, whereas Sahadev's was divided into 100 squares. Nakul ploughed 4 out of 10 squares, and Sahadev ploughed 41 out of 100 squares. The Pandavas and Kauravas were confused, and they went along with Nakul and Sahadev to Guru Dronacharya. Today, we will learn about equivalent decimals, like and unlike decimals, and comparing decimals.
Guruji, my brothers Nakul and Sahadev were having a competition among themselves on who will plough more land in the given time. The lands allotted to them were equal in area. Nakul's land was divided into 10 squares, whereas Sahadev's land was divided into 100 squares. Nakul ploughed 4 out of the 10 squares and Sahadev ploughed 41 out of 100 squares. How do we find out who ploughed more land?
Before we solve this problem, why don't I teach you about equivalent fractions? This will help you solve this problem and other similar problems which might arise in future.
Sure, Guruji.
Take a rope. Now divide it into 10 equal parts. Take 1/2 of the rope. We will observe that we have 5 parts, or in other words, we have 5 by 10 of the rope. In decimals, we denote this as 0.5. Now take a similar rope and divide it into 100 equal parts. Take 1/2 of the rope. We will observe that we have 50 parts, or in other words, we have 50 by 100 of the rope. In decimals, we denote this as 0.50. But since these ropes are equal in length, it means that the halves of the 2 ropes are also equal, which implies 0.5 is equal to 0.50. Hence, decimals 0.5, 0.50 and 0.500 are said to be equivalent decimals. Similarly, 0.2, 0.20, 0.200 are equivalent decimals. Also, 0.4, 0.40, 0.400 are equivalent decimals. From this, we can observe that placing any number of zeros to the right of the decimal part does not change the value of the decimal. Duryodhana, can you tell me an equivalent decimal for 0.25?
Since adding zeros to the right of the decimal part does not change the value of the decimal, 0.250, 0.2500, etc. are equivalent decimals for 0.25.
Very good. Bhima, tell me an equivalent decimal for 0.345.
As adding zeros to the right of the decimal part does not change the value of the decimal, 0.3450, 0.34500, etc. are equivalent decimals for 0.345.
Very good. Sahadev, can you tell me what is common about 0.34 and 0.67?
Guruji, both these decimals have 2 digits to the right of the decimal point.
Very good, Sahadev. Yes, both these decimals have the same number of digits. Such decimals are known as like decimals. Dusashan, can you give me two other examples for like decimals?
0.3 and 0.5, 0.928 and 0.567.
Very good. Decimals which do not have the same number of digits after the decimal point are said to be unlike decimals. In other words, the decimals which are not like decimals are unlike decimals. Arjun, can you give an example for unlike decimals?
0.1 and 0.23, 0.45 and 0.678.
Very good. Unlike decimals can be converted to like decimals. This is done by finding equivalent decimals for the decimal having lesser number of digits in the decimal part. Consider an example. We are required to make 0.56 and 0.789 into like decimals. By considering 0.560, which is an equivalent decimal of 0.56, and having the same number of digits in the decimal part as 0.789, we are converting 0.56 to a like decimal for 0.789. Yudhishthir, can you convert 0.7 and 0.256 into like decimals?
Since 0.7 has the lesser number of digits in the decimal part, we are required to find equivalent decimals for 0.7, and it must also have the same number of digits in the decimal part as 0.256. Hence, 0.700 and 0.256 are like decimals.
Very good. Now let us learn on how to compare two decimals, which is larger and which is smaller. Let us learn this concept with the help of an example. We are required to know the larger of 0.989 and 0.98. First, convert them into like decimals. Hence, we must find an equivalent fraction for 0.98. 0.980 fits perfectly, and 0.980 and 0.989 are like decimals. First, compare the whole number parts. The one with the larger number in the whole number part is the greater decimal. Since the whole number parts are equal, in this case it is 0, and we must check the decimal part. Check the digits in the tens place for both the decimals. The one with the greater digit in the tenths place is the greater decimal. Since the digit in the tenths place is same for both the decimals, that is 9 in this case, let's now proceed to check the hundredths place. The one with the greater digit in the hundredths place is the larger decimal. Since the digits in the hundredths place is the same, let's proceed to check the thousandths place. The one with the greater digit in the thousandths place is now the larger decimal. 9 is greater than 0. Hence, 0.989 is the greater decimal. Why don't we solve some problems to improve our understanding? Nakul can tell you which is greater among 34.789 and 54.128.
First, we must check the whole number part. Since 54 is greater than 34, hence 54.128 is greater than 34.789.
Very good. Bhim, can you tell which is greater among 23.678 and 23.456?
First, we must compare the whole number part. Since the whole number parts are same, that is 23 in this case, let's proceed to check the tens place. Here, 6 is greater than 4, hence 23.678 is greater than 23.456.
Very good. Now, why don't you solve the problem of Nakul and Sahadev?
Nakul plowed 4 by 10 of his land, which is 0.4 in decimal, whereas Sahadev plowed 41 by 100 of his land, which in decimal is 0.41. Converting 0.4 to 0.40 so that we get like fractions, compare 0.40 and 0.41. We see that the whole number and the tenths part are equal. 1 is greater than 0 in the hundredths part. Hence, 0.41 is greater than 0.4. Hence, Sahadev plowed more land.
Very good.
Today we have learnt about equivalent decimals, like and unlike decimals, and comparing decimals. Rahul, hope you understood all the above concepts.
Yes, the concepts are much clearer now. Thank you, Great Wisdom Tree.
You're welcome, Rahul. Goodbye.